Methods of increasing the motivation of mathematics students to implement elements of STEM education during the study of elementary mathematics. As noted in the Standards for Preparing Teachers of Mathematics, developed by the Association of Mathematics Teacher Educators, a modern teacher of mathematics must be ready to effectively form students' abilities to apply mathematics in real life. Integrative abilities at the intersection of various fields: mathematics, natural sciences, modern technologies, engineering, art. One of the modern trends today is STEAM education. A critical aspect of effectively implementing STEAM education is fostering teachers' motivation to integrate STEM elements into their mathematics instruction. Elementary mathematics is an important mathematical discipline from which the training of students of higher education in mathematical specialties of pedagogical universities begins. This discipline creates opportunities for improving the abilities of mathematical modeling, demonstrating its role in STEM education. This determines the relevance of the problem of teaching elementary mathematics, aimed at increasing students' motivation to implement elements of STEM education. The purpose of the article is to present the method of increasing the motivation of mathematics students to implement the elements of STEM education through teaching the elements of mathematical modeling in the course of elementary mathematics. The authors have devised a methodology for fostering students' motivation towards STEM education during their elementary mathematics studies. This methodology encompasses 3 stages, which are detailed in the table presented on the slide. Stage 1 immerses students in solving tasks purely related to the natural, technological, engineering, and mathematical domains. The primary goal of this stage is to equip students with the skills and expertise to tackle problems across diverse fields. Collaborative learning forms the cornerstone of this stage. On the slides you can see examples of such tasks. Stage 2 involves tackling a single integrative task that seamlessly blends all STEM components. The objective of this stage is to cultivate motivation towards acquiring the skills to solve diverse STEM-oriented problems. Initially, individual work is employed, followed by group collaboration. A unique aspect of this integrative task is that its solution demands the skills and expertise gained from solving the individual tasks presented in Stage 1. Stage 3 involves the construction and solution of practical and applied tasks from various sections of elementary mathematics. The objective of this stage is to equip students with the ability to construct and solve diverse tasks in elementary mathematics, as outlined in the discipline's curriculum and aligned with STEM principles. Collaborative learning forms the cornerstone of this stage during practical classes. Forms of student activity within the framework of the proposed methodology: STEM project, STEM quest, a team search game, the main principle of which is the step-by-step execution of previously prepared logical tasks aimed at obtaining a single final result, STEM hackathon, joint activity of specialists, teammates with different interests, of STEM fields working on solving a given problem or creating a new product. Results: the experimental research was conducted during the academic year 2022-2023 and aimed to address 2 primary objectives. 1. To ascertain the level of understanding among future mathematics teachers regarding the concepts of STEM and mathematical modeling, to gauge their perspectives on STEM education development, and to refine the content and organizational components of the methodology for fostering motivation among mathematics students to incorporate STEM education elements. 2. To evaluate the effectiveness of the proposed methodology. As you can see on the slide, This presents an example of student responses during the first stage of the experiment. As you can see on the slide, this presents an example of student responses during the second stage of the experiment. This study proposes a three-stage methodology for fostering motivation towards incorporating STEM education elements into elementary mathematics instruction. During this initial stage, students engage in the construction, investigation, and interpretation of mathematical models within the context of solving individual tasks related to science, technology, engineering, and mathematics, STEM. In Stage 2, students progress to applying mathematical models in the context of solving integrative tasks. These tasks, designed to encompass all 4 STEM disciplines, challenge students to think critically, integrate knowledge from various fields, and apply mathematical concepts to solve complex problems. The final stage of the methodology culminates in students constructing, analyzing, and solving applied and practical tasks related to various sections of elementary mathematics and STEM professions. Empirical verification employing statistical methods confirmed the effectiveness of the methodology for fostering motivation towards incorporating STEM elements into future pedagogical practices. Vision promising avenues for future research in developing a methodology to cultivate students' capabilities in incorporating STEM elements into the study of fundamental mathematical disciplines. Thank you for your attention.